Here we go. No talking, please. Negative 150. Our goal today is to get through 6 problems. Negative 150. You are going to be provided with an XY axis, and the first thing you have to do is you have to graph it correctly. Then you're going to be asked a series of questions. One is, what is that reference angle? The next is to convert it into radians. Okay, there's always markers up here, Alex, as always. Okay, so you're ready. Negative 150. I'm going to count. Can you do me a favor, Alan? Alan, can you shut the door for me, please? I'm going to count, and I have to go backwards because it's negative. So please, if you're taking notes on paper so you can use it tomorrow, please put a little arrow above the negative sign. That means we're going to reverse it backwards. And I'm counting by 3s. So here we go. 3, 6, 9, 12, and 15. In my opinion, this class does a phenomenal job of getting to this point. Doesn't mean everyone does, but the majority of you do. The majority of you don't have a problem with that. Now, just like we learned yesterday, please go directly back to the origin and go straight up to the x-axis every time. I think Andy was the one who articulated to me where the confusion was, and I have learned a better way of explaining it that I think will help the vast majority of you. I just copied down that triangle. I'd like you to do the same. I just copied down that triangle. Now, from here to here is 150. That's how I got there. This is 150. Yes, that's reversing, so it's negative 150. But half of a circle is 180. So on the calculator that I provided, or the mental math, I'm going to take and do 180 subtract 150. And whatever I get, and again, you can use mental math if you need to, whatever I get is going to be this interior angle. So this is going to be 30 degrees. So in this spot, please write 30 degrees.
Is it always going to be 30?
Nope. We're going to do the next one. It could be 60, it could be 45. Yep. Okay, so now, Andy, do you understand how I got 30?
I have one question. How did you get 180?
Because half of a circle is 180.
Do you always do it like that?
It's always back to the x-axis, every single time. Whether it's above or below, it's always back to the x-axis. What is the distance back?
Are we just rounding out the number?
We are just figuring out from wherever I stop, how much more do I have to add to get to 180? Or how much do I have to go backwards to get to 180? Always above or back, but it has to always go back to this line right here, every single time. Yep, every time. Now, I will put this on the board, but I want to just make sure all earbuds are out. It's disrespectful to me right now. If you have, make sure all earbuds are out. Just raise your hand, and honestly, if you don't, I'm not going to call on anybody. Who knows right now what is always opposite of 30 degrees? I'm just seeing what you remember. Wow. You got like 4 or 5. Nice. Opposite of 30 degrees is always 1. Always 1. But that's going to be on the board. You just have to know how to look in the board and to make sense of it. Okay, opposite of 60 degrees is always going to be the square root of 3. And this diagonal line, which is opposite of 90, is always going to be 2. Now here's where I learned from other teachers yesterday. I was like, I'm doing a crappy job. Like, too many of my kids, and I have a smart third hour, are not getting this. It's something that I'm doing wrong. So it's the angle that's closest, it's the angle closest to the origin that we always are going to evaluate. So I'm going to highlight this. This would be the angle closest to the origin. That's the one. So we don't always say, hey, I'm going to evaluate 60, or I'm going to evaluate 45, or I'm going to evaluate 30. It's whatever angle is closest to the origin. Okay, are you ready? So here's what I learned yesterday. Want to grab that for me real quick? Maybe the tutors? Yeah? Did you find it? Okay, so here we go. The diagonal, so we can see that we have 3 sides. The diagonal or slant is always the hypotenuse. So on your desk or on your paper, find the diagonal. Only one of those 3 sides is a diagonal, and I'm going to abbreviate it. Or just put an H if you want to. That's the hypotenuse. The side that corresponds, that is exactly the same as the x-axis, is always, always, always going to be the adjacent side. The side that's exactly the same as the x-axis will always be the adjacent side. And there's only one other term. What's that other term we haven't said yet? So I'm going to put OPP over here. Okay, now let's write down sine, cosine, tangent. And then I'm going to write down cosecant.
Does it always have to have that 0?
Yep, that just means the angle. That 0 is called theta. It just means the angle I'm going to evaluate. Next question for you is, if I put this down, again, I don't want you to yell it out. If I put this down, and I'm not going to call on you, who knows what this even means? Hands up high if you do. Who knows what this means? Okay? This tells us where things, so if you want to write this down on your paper, it will be on the board, but I will not explain it to you tomorrow. This tells you where things are positive. So the A means all things are positive. I will not answer any questions tomorrow, but any notes you take, you can use tomorrow. Everything is positive here. All things. What?
What do the rest stand for?
S stands for the sine. Only sine and its reciprocal are positive. T stands for tangent. Only tangent and its reciprocal are positive. And C stands for cosine. Only cosine and its reciprocal are positive. So,
Good question. What is the radian?
what is the radian?
Yeah, convert to radian.
We're going to do that afterwards. Yep. So here we go. Are you ready? So the first thing I do is I ask myself, where did we land? We landed in quadrant 3. In quadrant 3, tangent is positive and it's reciprocal. So I come over here, I put a plus sign and a plus sign. And everything else gets a minus. Now sometimes students ask me, like, where does a minus go? As long as there's one minus, that's all that matters. Thank you, by the way, for your focus right now. Okay, now each one of these, I want you to draw a little division sign. Because we're going to just compare two different numbers. We're going to compare two different numbers, making a ratio. A ratio is just a division of two things. This will be on the board. Well, I just took it off. Let me find it for you guys. Right here. This will be directly on the board. Can everybody see this? Yes, yes, yes? This will be on the board. You just have to know, what does that mean? So let's start with the sign. We're going to identify what of the three sides represents opposite and which of the three sides represents hypotenuse for this triangle. Okay, ready? So sine is opposite of hypotenuse. Let's find it. So here's my triangle. Which one of these is opposite? 1. And which one is hypotenuse? 2. Okay, we're done. We'll come back to that later on. Now let's flip it. 2 over 1. Because sine is reciprocal, you just flip it. Keep the same sign, flip. Okay, now cosine. I need adjacent over hypotenuse. So I come over here. Which one is adjacent? Adjacent is square root of 3. Hypotenuse is 2. And then let's flip it. I'll come back to that later on. Tangent is opposite over adjacent. Okay, opposite, here's opposite, so that's a 1. And then adjacent is the square root of 3. And then, dang, and then I'm going to flip it. So square root of 3 over 1. Okay, you ready? I'm going to come back and make them pretty in 1 second. And then, so if you're wondering, how do I know if, like, this is my final answer, you're going to look to see, do any of these have a square root in the bottom? If they don't have a square root, that's my final answer. No square root, boom. No square root in the bottom, done. No square root in the bottom, done. Uh-oh, we got a problem here. We got a square root on the bottom. So here is your fast way of rewriting it in an equal form, but it's proper. We take the bottom and we throw it up top, and then we rewrite the bottom with no square root on the bottom. Here again is another example. We can't have a square root in the bottom. So keep the top, throw the bottom up top, and then rewrite the bottom with no square root. We're looking at our second example. So I'm going to count right now by 3s. Notice it's positive, so I'm going to start here and go up. 3, 6, 9, 12. Although it's a sketch, I want it accurate. Go back to the x-axis. Go straight down and make that 90-degree angle. Now this is what Mello was just asking. This is actually called the reference angle. So what reference angle means is, hey, I know it takes 120 to get here. That's how I just came up with that. But I want to get back to this axis. So do not say it out loud because I want people to think. What I need to think in my mind is, what do I need to add to 120? So 120 plus what amount brings me back to the x-axis, which is at 180.
60.
It is 60, and if you didn't know that, you take 180, subtract 120. Whatever we get is that inside angle. It's called the reference angle. So 60 degrees. This is 60. So I'm going to redraw this triangle. This is 60. What will the other one be, kiddos? 30. Okay? Wrong answers are okay. Wrong answers are okay. This will be on the board, but you have to know how to apply it. What's always opposite of 30 degrees? 1. What's always opposite of 60 degrees? And the diagonal or opposite of 90 degrees is 2. You're good at this. So here is the angle. And you're like, well, how did I know which angle? It's always the angle that's closest to the origin. Please make sure you're not talking. I'm going to see if I can find a colored pen that's different here that would stand out. We will just go, here's my pink pen. All right, you ready? So the diagonal is always going to be opposite of 90. The diagonal is always the hypotenuse. So I'm going to write hypotenuse here and abbreviate it. The side that is exactly the same as the x-axis, the side that's exactly the same as the x-axis is always the adjacent side. So that's this side. I'm going to write adjacent, abbreviate. And we only have one side left. That's opposite. We only have one side left, and that's opposite. I think once you have those identified, then it's pretty easy to look up on the board tomorrow, and we're going to create these ratios. Now, this landed in quadrant number 2. In quadrant number 2, I see an S. What does that mean? Turn to your group. You have 5 seconds. What does that S mean? It stands for sine. It means only sine, and it's reciprocal or positive. So sine and its reciprocal are positive. Everything else gets a negative. Everything else gets a negative. Next up, we are going to make some division signs here. Make some division signs. And we're going to create a ratio. We're going to compare 2 of the 3 sides of the triangle, but the order matters. So now it's like just following a manual. So I'm going to start with sine. I wanted to go, what's the opposite side? What's the hypotenuse in that order? What's opposite? What's hypotenuse? Okay, here we go. So here's my angle. Opposite is the square root of 3. Hypotenuse is 2. Shh, shh. And then I flip it. Cosine. What side is adjacent? What side is hypotenuse? Okay, in that order. Adjacent is 1. Hypotenuse, I'm so sorry, hypotenuse is 2. And then I flip it. Tangent is going to be opposite over adjacent. Opposite over adjacent. Okay. Opposite is going to be square root of 3, and adjacent is 1. And then I flip it. All of those are great mathematically, but just like we say when you're going to write some type of a paragraph for your English class, we start off every sentence with a capital letter. It's proper. Well, proper means no square roots in the bottom. There's no square root here. I'm done. Oh, we got a problem here. We got a square root. So 2 square roots of 3 over 3. Make sure to include the sign. Oh, there's no square root in the bottom. We're done. No square root in the bottom. We're done. No square root in the bottom. We're done. Oh, we got a problem. Make sure to include the symbol. So, I'm seeing people doing a great job of finding this. So they're reversing it. They're doing 1 revolution. And then they still have 120 remaining. So they're going to do 120. 3, 6, 9, 120. So they're going all the way to here. And then they're drawing that line, and they're going straight back. Please listen. So I'm seeing great job of students understanding this. That's part of it. Here's where they're getting confused. This angle that they know they have to evaluate, they're like, how do I get that? Well, here's 120. How much more do I have to add to 120 to come up with 180? Because we always go back to the x-axis, which is 180. So you can grab your calculator if you choose and go 180 minus 120. That gives us this interior angle called the reference angle of 60 degrees. This is 60. If you put 60 in the wrong spot, you're going to have the wrong answer. So across from 60 is the square root of 3. Across from 30 degrees is 1. And the diagonal is 2. Now, this is the angle that I'm going to evaluate.
When do we know where the 60 is?
Whatever you get when you subtract is always going to be the angle closest to the origin. Does that help? Okay, so here we go. The diagonal is always the hypotenuse. And the side that's the x-axis is always the adjacent. And then we only have one side left, opposite. So let me just call on students and let's see if you can do this. Are you ready? Here we go. Milagros. We have 6 different trig functions. Which of these 2 will be positive? Tangent and its reciprocal. And now how did Milagros do that? She probably said, okay, this landed in quadrant 3. Quadrant 3, tangent and its reciprocal are positive. All right. Next up, Casey, can you tell me the words that describe the ratio for sine? So you're going to be like, what over what? Don't tell me the numbers, tell me the words. Yep, so from this angle, the opposite is the square root of 3. The hypotenuse is 2. And then I'm going to flip it, 2 over the square root of 3. Kevin, can you tell me the words that describe the ratio that we use to create cosine? So adjacent is 1, hypotenuse is 2, and then I flip it. Leo, can you tell me tangent? Opposite over adjacent. Okay, opposite is the square root of 3, adjacent is 1, and then I flip it. Okay, it's in proper form. I got to rewrite it in proper form, but don't forget about that negative. It's in proper form, and I rewrite it. Please don't talk. So how do I find 225? Well, 225 is going to be a 45 degree, and I got to go reverse it. So I'm going to start counting by threes. 3, 6. So this is like 30, 60, 90. This is like 120, 150. Here's 180. Okay, here we go. Here's 210. Here's 240. Directly in between 210 and 240 is 225. So go directly in between them. It cuts that quadrant right in half. These two are identical in size. And then go directly back to the x-axis, just as always. And then I'm going to draw that picture.
So wait, what happens when you subtract?
We're going to do it right now. We're going to do it right now. So we went all the way up here to 225, but I've got to go back to 180. So 225 minus 180, that's going to tell me this angle called the reference angle. It's the one closest to the origin, which is 45. What are the only numbers we're going to have that we're going to be working with right now, these common angles? 30 degrees, what else? 60 degrees and 45. This is the angle we're doing. Okay, look back in your notes. What was across from 45? If you don't have it, you should write it down. Its ones are across from each 45, and the diagonal is the square root of 2. Every single time. Across from the 45s will be 1s, and across from 90 degrees, or the diagonal will always be the square root of 2. So in this case, the diagonal, again, is the hypotenuse. The side, please don't talk when I'm talking. The side that is the same as the x-axis is the adjacent. And then opposite is the only one remaining. All right, are you ready? Please, right now, evaluate the 6 trig functions, and I will go over them in 2 minutes. Make sure your signs are correct and they are in proper form. Thank you. That angle closest to the origin is the one we're evaluating.
Okay, so this one right here, this is since this is close, there's 45, you know, right? So whenever it's a 6 meters, it was going to get another triangle. But when it's upward, I mean, both is going to be 45. So that is going to be when it's 45, so it's going to be like that. Yeah.
Brielle, which quadrant does this terminal angle land in? 1, 2, 3, or 4? 2. And in quadrant 2, what's the only thing that's positive? The sine and its reciprocal. So I'm going to find sine and its reciprocal. They get a plus sign. Everything else gets a negative. And then I make my lines. Sparkles, what 2 words in the order, when you look at the ratio, describe sine? What words? What over what? Opposite over hypotenuse. So, right here, the opposite is 1. The hypotenuse is the square root of 2. And then I flip it. Manny, what 2 words describe cosine? Adjacent over hypotenuse. So I find adjacent. Okay, that's 1. Hypotenuse is the square root of 2. And then I flip it. And let's go, Melanie. What 2 words describe tangent? So opposite over adjacent. Opposite in this case is 1. Adjacent is 1. And then I flip it. All of this is great mathematically. I have the right signs, but this isn't proper. We have a square root in the bottom. So I throw it up top and put 2 in the bottom. This is good. There's no square root in the bottom. Same thing here. I throw it up top and put 2 in the bottom. Notice that I have to include that symbol with it. Good form, and good form.